Okay, thanks for having me. So this is joint work with my former colleagues at the University of Zurich, Bjorn Bartling, Todd Hare, and Ernst Fehr. Okay, so this is a paper primarily about dual process theories. Okay, dual process theories have become quite popular lately, in no small part thanks to Danny Kahneman. And the dual process theories is actually a collection of theories. And the running theme with these theories is that different behaviors may be governed by different systems, particularly two different systems. System one is a system that's intuitive, it's automatic, and for the purposes of this paper and this argument, they're fast. It's the fast from the fast and slow. System two, on the other hand, is more sort of the deliberative, controlled, and importantly, the more slow system. So the idea is that in some situations, both systems may be at work, and you may make a quick, fast decision, or you may detect some conflict, perhaps, and then slow down, make a more deliberative decision. Okay. So why do we care about dual process theories for this conference? Well, if we think that dual process theories are involved in social preferences and, say, charitable giving, and we see someone, say, give money to a charity, we want to know whether that choice to give to a charity is just an automatic response, that person just saw charity and felt like they needed to give to it, or whether that decision was a carefully calculated decision, like this is a worthy cause, I want to give to this charity. And whether that decision to give is automatic or deliberative is going to have implications for how we encourage people to give more. Right? So we need to understand what's really going on here. So there's this prominent paper that came out a couple years ago in Nature that basically addressed this point directly. So this paper is called Spontaneous Giving and Calculated Greed. Right? So they lead off saying, intuitive responses are relatively fast, whereas reflective responses require additional time for deliberation. So what they do is they do a series of experiments, but the experiment number one, the motivation for this paper was a public goods experiment. And what they found was that subjects in this one-shot public goods experiment, the subjects who decided more quickly contributed more in the public goods game compared to the subjects who decided more slowly. Right? So subjects who decided more quickly were more pro-social. And from these data, Rand and colleagues concluded that subjects who reach their decisions more quickly contribute more in the one-shot public goods game. This suggests that the intuitive response is to be cooperative. Okay? And this paper has touched off a whole swath of new papers that are coming out, tons of working papers that are popping up, that are looking at reaction times and arguing that, well, yes, Rand is right, Rand and colleagues are right, cooperation is indeed intuitive. There's an equal number of papers saying no. In fact, selfishness is intuitive because selfish choices are faster in their data set. And there's a third class of papers that are saying no significant effects at all. So there's no evidence for dual processes. So anyway, so this paper is trying to address this body of literature that's emerging. So this paper is not a focused attack just on Rand et al., nor is it a critique of the time pressure results, though those results are controversial and have been questioned by several other papers that are out there. Nor is this paper an attack on dual process theories. I'm not saying that there's clear evidence that in some cases dual process theories are at work. Kahneman has laid out a lot of settings where there is good evidence for them. Okay, but the question is, does dual process theory apply in social decision making? So what this paper is it's a general critique of the method or the idea that you can use response times to infer distinct mental processes. It's really a methodological point. Okay? So here's just a few representative quotes from some papers. Again, there's plenty more out there. So here's one quote from Lotito, Migeli, and Ortona. They look at reaction times in a public goods game like Rand's paper. They say results seem to support the hypothesis that cooperation is instinctive while defection is rational. We also detect that females seem to behave less instinctively than males. Interesting. Males chose more quickly, so they're more instinctive. Piovazan and Wengstrom looked at dictator games, so they find sort of the opposite. So they find, based on their dictator games, that the selfish guys are faster. So they say, our results may be interpreted as if egoistic subjects have no conflict between effective and deliberative reactions, and therefore make fast decisions. On the contrary, social subjects do have such conflicts. So they're going the other direction. Going a little bit further back in time, Ariel Rubinstein was actually one of the first to make these sorts of inferences. So he looks at a bunch of sort of more game theoretic type situations, strategic situations, and writes that large response time differences provide a hint as to which is the instinctive action. Okay? So my critique of this literature is called a reverse inference critique. I've actually borrowed this term from the neuroimaging literature. And the critique goes as follows. So there's a key distinction between two claims. The first claim is forward inferences, which is saying, given that we know this is an automatic process, it should occur faster than a deliberative process. That's fine. The reverse inference is to say that because a choice is intuitive or automatic because it happens more quickly. Right? And the problem is that other factors can influence response time, not just intuition or deliberation. Okay? Namely, there's one particular big body of literature that's out there looking at drift-diffusion or evidence accumulation models. And I don't have time to go into the details of this particular task, but needless to say, this trend shows up in any number of different preference-based decision tasks. And the basic phenomenon is when you look at strength of preference, so take this difference rating as like a utility difference, and you look at the correspondence between utility difference and the probability of choosing the item with the higher utility is estimated by like a utility function or ratings. What you see is a standard logistic choice curve. So when the difference in ratings between the two options is 0, subjects are indifferent between choosing left and right, so they're at 50-50. As the strength of preference increases, subjects are more likely to choose, say, the left option as left gets better, or the right option as right gets better. That's the black curve. The red curve are their response times. And what you'll notice is that the response times are highest when subjects are indifferent, and then they go down symmetrically as the strength of preference goes up. Okay, and this is an extremely robust result. Temporal discounting, social preferences, food choice, counting dots on a screen, it always looks like this. Okay? So how does this apply to social preferences? So in the social preference, so the general finding is that the stronger the preference, the shorter the RT. The easier, think of it as easy and hard. An easy decision you're going to make quickly. A hard decision you're going to take some time. Right? So in a social domain, now imagine we have selfish people out there and we have pro-social people. So we have heterogeneity. So selfish people in a given experiment are going to tend to choose more selfishly. They're going to make those selfish choices more quickly. And they're going to make when they do make pro-social choices, they're going to make those choices more slowly because they're going to be closer to their indifference point. For pro-social people, they, on the other hand, they're going to tend to choose more pro-socially. They're going to make their selfish choices slowly, and they're going to make their pro-social choices quickly. Because for pro-social people, being pro-social is easy. That's what they prefer. Okay? So you don't have to take my word for it. So let's look at an experiment. This is an experiment with a binary dictator game. We had 25 subjects. We had 70 unique binary dictator game decisions. So a typical trial would look like this. So you choose X. You could choose between X, which is sort of a selfish option. So I get 1,000 points. You get 190 points. And then there's a more fair option, where I get 730 points and you get 470 points. For instance, we have 70 unique trials like this. Okay. So if we just look at this experiment, this is an experiment we'd already collected, so we're retroactively looking at this experiment. And we just look at all the trials where subjects chose the more fair option versus all the trials where the subjects chose the more selfish option. What do we find? We find support for intuitive selfishness. So subjects who chose more selfish, so trials where subjects chose selfishly, they were faster than on trials where subjects chose the pro-social option. Okay, so if we just did this basic analysis, we'd throw our hat into the ring and say, one more piece of evidence that selfishness is intuitive. Okay, but let's look at the data a little bit more carefully. So let's look at individual subjects now. And let's look at the probability. So each subject, again, has 70 trials. So we can look at, across those 70 trials, what is the probability that the subject chooses the selfish option? Okay, and then on the y-axis, we can look at the RT difference, the median RT difference for all that subject's pro-social choices versus that subject's selfish choices. Okay, so a positive number here would mean that subjects that a subject made their selfish choices faster than their pro-social choices. So if you look at subjects way on the right here, these are subjects who are almost always choosing the selfish option. Okay, they tend to have positive values for this difference. So the subjects who are choosing selfishly are choosing the selfish option more quickly. Okay. On the other hand, subjects, when you drop below 50% down here, subjects who are more often choosing the fair option, the pro-social option, now their value on the y-axis is negative. Right? So they're actually faster at choosing the more pro-social option, the fair option. So what's the problem? Why are we getting this result? Well, we're missing data, right? We don't have a perfectly balanced experiment. Right? If we had more trials in there where we asked subjects, do you want to take 50 cents for yourself or $100 for someone else? Well, we'd shift this probability of selfish choices downwards, and we'd fill in this data, and we would balance out the RTs for selfish versus pro-social choices. But because we didn't design our experiment that way, we're missing this part of the x-axis, and so our RTs are biased towards faster selfishness, simply due to the trials we chose for our experiment. Okay. So what we can do is we can actually try to account for this by fitting Fair-Schmidt utility functions to each subject, and then asking if there's a bias towards selfish or cooperative choices, we should see faster decisions after controlling for the utility difference. Right? So if we can look at equally attractive selfish choices and pro-social choices, if there's indeed an intuitive preference for selfish or pro-social choices, we should see a RT difference. And we don't. Right? So what we've done here is just binned utility difference for chosen minus unchosen, and then in red is the pro-social choices, and in black are the selfish choices. And what you can see is that there is no difference in any of those utility difference bins for the selfish versus pro-social choices. And if you don't like binning, you can do just a mixed effects model, and you see a strongly significant effect of utility difference on RTs, but no significant effect of choice type. So that's just a dummy variable for did you choose selfish or pro-social. So we see no evidence that one type of choice is faster than the other. So the take-home message from experiment 1 is, had we presented trials more favorable to giving, or perhaps had more pro-social subjects, we would not have seen that observed RT difference. So the RT difference for pro-social versus selfish decisions depends on A, the subjects we have, but B, more importantly, on the questions we ask. Right? These RT differences are very likely due to artifacts of our experiment. Okay? So we want to address this more, a bit more specifically. We want to go back to the original RAND experiment with the public goods game and see if we can actually produce arbitrary reaction time differences. Right? So this is actually, in the interest of time, let me skip ahead. So this is our experimental design. So we brought 204 subjects into the lab. They made 3 decisions each, and we randomly paid 1. Subjects were randomly assigned to groups of 4 for each decision. This is all following how Rand et al. did their experiment. So each subject has 40 points. Points are converted to cash. And they contribute those points, and the points are then distributed evenly amongst the 4 subjects in the group. The difference between our experiment and Rand's experiment is that in the Rand experiment, they only ran one condition where for each point that was contributed, another point was contributed. So essentially, the points that were contributed were doubled and then split between the 4 group members. So that works out to an MPCR of 0.5. What that means is for each dollar I contribute to the group, I get 50 cents back, but the other 3 guys in the group also get 50 cents back. What we did is we ran three versions of the game. We ran the Rand version with MPCR of 0.5, but we also ran 2 other versions, one with an MPCR of 0.3. So this is a pretty bad public good, right? Not that efficient. And we also ran a particularly good public good with an MPCR of 0.9. So again, every dollar I put in, I'm getting 90 cents back, and everyone else is also getting 90 cents. And then we had 2 comprehension questions at the end, which we excluded 29 subjects. Again, all in line with the Rand et al. Experiment. Okay. What we found, in line with previous work on public goods, is that sure enough, subjects do indeed respond to the MPCR. So as the public good gets better, as more efficient, contribution rates climb from 25% to 48% to 63%. Okay. But now let's think about what the predictions would be for reaction times and contribution rates in these different versions of the experiment. Okay. So here are 3 different predictions. Okay, so what I'm plotting here, it's hard to read, on the y-axis is the contribution out of 40 points, so 0 to 40. And on the x-axis is each color is a different game. So blue is the MPCR of 0.3, so that's the bad public good. The red is the MPCR of 0.5, that's the medium public good. And green is the MPCR of 0.9, that's the good public good, the high efficiency one. Okay, and then the left bar is the subjects who make their decisions quickly, and then the right bar is the subjects who make their decisions slowly. So it's fast, slow, fast, slow, fast, slow. Okay? So the prediction from the intuitive cooperation viewpoint put forth by Rand et al. And various others is that, well, if people are automatically predisposed towards giving, then what we should see is that in all 3 games, regardless of the MPCR, subjects who decide more quickly should contribute more. Right? So the bars for fast versus slow, there's always a positive difference. So no matter what game we're in, subjects who decide more quickly should contribute more. That's explanation 1. Explanation 2 has been put forth. This would be sort of the Ariel-Rubinstein explanation, also put forth by Lisa Westerlund and Arno Riedel. And their explanation is that subjects in this game are just confused. Okay? When subjects are deciding quickly, that's telling you that they haven't really thought through the game. Right? So the prediction there would be when you have a pretty bad public good, right, the MPCR of 0.3, subjects who decide quickly, they're the ones making mistakes, so they should contribute more. That should push their contribution rates up towards 50%. So the subjects who think it through don't give much. The subjects who think quickly, they contribute more. On the other hand, for an MPCR of 0.9, I think most of us would agree that subjects probably should be contributing in that game. It's still a dominant strategy if you're purely self-interested, but given a little bit of social preference, contributing with an MPCR of 0.9 is probably the right thing to do. So subjects who think more slowly will contribute more in that game, and subjects who decide more quickly will contribute less. So again, choosing quickly is going to push you towards 50%. That's the confusion story. Okay, and finally, there's the strength of preference story from the drift-diffusion models. And that makes sort of the opposite prediction from the confusion story. So the drift-diffusion model prediction is that for the bad public good, right, when you have a bad public good, for most subjects, even the pretty pro-social ones, that's a pretty easy decision. Okay? It's a pretty easy decision to say, yeah, MPCR of 0.3, I think I'll just keep the cash for myself and not contribute. So subjects who decide quickly are going to contribute less, and the subjects who decide more slowly are going to contribute more. Whereas for a very good public good, so again, you're only giving up 10 cents to give 90 cents to 3 other people, that's a pretty easy decision for most subjects. So the subjects who decide quickly are going to contribute more, whereas the subjects who decide more slowly, they're the ones who are sort of conflicted. They're probably going to contribute a little bit less. Okay. So here's our 3 horses in the race. Which one wins? There's the data. Okay, so strong support for the strength of preference explanation, and clearly rejecting the intuitive cooperation and the confusion explanations. Right, so indeed, subjects who are fast are actually doing the smart thing. They're not contributing in the bad public good. They are contributing in the good public good, and in the middle, they're sort of in the middle. Okay. So they're not confused, and they're not just automatically contributing. They may be confused, but most of them are not. Some of them are, but we excluded them because they didn't get their questions right. Okay. So the conclusions, it's generally problematic to interpret reaction time asymmetries as evidence for dual process models. You would have to have a perfectly designed experiment where subjects were perfectly indifferent on average between choosing one option or the other. Now, I'm not saying that Ariel Rubinstein is wrong or that Lisa Westerlund and Aaron Riedel are wrong. So in complicated settings, in strategic settings, or in interactions where you need to collect information over time or strategize, then fast decisions may be indicative of people not thinking about the problem very carefully and making mistakes. But in many other cases where we're just eliciting preferences, what seems to be the case is that fast decisions are simply indicative of a strong preference. It's an easy decision. Right? And so those are very different explanations and very different ways to interpret reaction time data. So the take-home message is you really need to understand your task well and think a lot about subjects' preferences when you start interpreting reaction time data.
So I think one should be a little cautious if you're looking at reaction times, response times in the range that you're looking at. 1 second in cognitive time is a lifetime. And so when you look at the kind of choice decisions that people can make, they can make a evaluative choice decision in 200 milliseconds. So you're looking at choice times that are 5 to 10 times that at the base level. And I would suggest that nothing people are doing here is intuitive. It may be thoughtless, or it may be less evaluative or less strategic, but there are a lot of ways of evaluating the internal structure of the sequence of choice points besides just the time it takes. And so I'm very concerned about using the term automatic for anything that is well over 300 milliseconds in time.
Yeah, I completely agree with you on that. It's clear. I mean, the problem is that there's no great definitions of what constitutes automatic, especially in settings like this. They ran it all arbitrarily. I don't know if it was arbitrary, but they said 10 seconds was the limit. But where did that come from? Yeah, so that's a great point.